All right, everybody, welcome to a new unit. This is Unit 2, Day 1 and 2, and we're going to focus on perfect squares and cubes. Now let's make this nice and simple. This does not need to be a difficult task for anybody. Considering the fact that we do not have a calculator, let's make things simple. You already know perfect squares. Perfect squares are already on multiplication charts, and you've seen these charts for an awful long time. A multiplication chart is, or shows off the perfect squares on the diagonal that starts in the upper left-hand corner and travels down towards the bottom right-hand corner, because a perfect square is simply a whole number times itself. So the number 1 is a perfect square, number 4 is a perfect square, and so on. These are all perfect squares. So if you can visualize or you have access to a multiplication chart, you already have a list of the perfect squares, or the most common perfect squares. Now what happens if we don't have a chart that's big enough? And let's imagine that we have a number like a 12 squared, or 12 times 12, and we need to know what 12 squared is. Well, we already know it's a perfect square, but to figure this out, this is just 12 times 12. So let's not make it harder than it needs to be. We multiply 12 times 12. 2 times 2 is 4. 1 times 2 is 2. Bring down to 0. And now 1 times 2 is 2. 1 times 1 is 1. And we add these together and we get 144. That's it. So 12 squared equals 144. So what you should see here is that it is not difficult to get yourself a perfect square, even if you don't have it listed on your chart. Now, with the knowledge then that you could calculate, well, any perfect square, let's go ahead and go to the next piece. This symbol here, which is called a radical sign, but is more generically called a square root, is a reference to the fact that something squared and something square rooted, those things are often considered opposites. In fact, I have them marked here. The squared and the square root are opposites of one another. Now let me show you what that means. If we have ourselves a representation of a square, all right, so we have it here. Let's cover it up. So if we have ourselves a square, if we have a square and both sides are whole numbers, then if we take the whole number squared, we get the area of the shape. And as a reminder, the area of the shape is what this square covers. We also have another understanding. If we take the area of a square and square root it, we get the whole number side length. Now, let's clarify what that means. If I gave you a square that had a side length of 7, you could immediately do 7 squared and get 7 times 7 is 49. And you could tell me that the area of this square, the surface that it covers, is 49 square units. I could do the reverse of that as well. If I gave you a square that was, let's say, 100 square units, what you could tell me is, well, we could figure this out. What number squared equals 100? And if you're not sure, here comes the symbol, the square root of that and the square root of this. Now, this doesn't really help us. However, the square root of 100 will mean what number times itself is 100. We could come up with the number 10, and now we know that 10 is the missing side of a square. So that is what a square root is. A couple other little minor details. This symbol, one more time, is called a radical symbol. A radical symbol has two pieces to it. It has a number that sits on top of what I'll refer to as the little diving board. That number is referred to as the index. And the number that sits on the inside is often referred to as the radicand. And the final piece that's important is we all have a lot of numbers in math. You'll see some invisible numbers as well. The number that defaults onto the diving board, that the index is the number 2. If you do not see a number here, assume that it is the number 2, and we just don't write it. You're allowed to write it, you just don't need to. Now, with that in mind, squares and square roots should be somewhat understood. So let's go ahead and do the second part of this, and we'll be done with this first unit, or this first day. A perfect cube is quite simply the same as a square, but it's been made three-dimensional. It has an extra dimension. So if I have a cube, think Rubik's Cube, that has a whole number and the same whole number for the depth and the height, then the volume of this cube is the whole number cubed. Now, I don't have a chart to display this one, but the idea would be the same. If we had A number like 3 to the third power, that would be 3 times 3 times 3. So 3 times 3 is 9. 9 times 3 is 27. So we could conclude that 3 to the third power is 27, and 27 is an example of a perfect cube. Just like the one before, if we get a number that's bigger and we need to calculate it, we go ahead and, well, we work through it. In the previous example, we already calculated that 12 times 12 was 144. So now I'm going to do times 12 again. What you'll notice is that I have the base of 12 written 3 times. 1, 2, 3. That means that whatever I get here is my answer. So 4 times 2 is 8. 4 times 2 is 8. 1 times 2 is 2. We bring the 0 down. 1 times 4. 1 times 4. And 1 times 1. I'm going to add my columns. 12 carry the 1. 6 plus 1 is 7. And 1. And now what I know is 12 to the third power, not a number I'm going to need to memorize, but I could easily calculate it, is 1,728. Now, if we're going to talk about cubes, let's talk about cubic roots, which are very similar to what a square root is. It's just for cubes. All right. Once again, here's that same radical that you saw before. In this example, the index is a 3, and if the index is ever anything but the number 2, that was the default. If it's not a 2, we will indicate the index by writing the number on the diving board. So if you see a number here, then pay attention to that number. The 343 is considered the radicand in this case, and here's what this question is asking. It's saying, what number can be multiplied by itself? What 3 numbers can be multiplied by themselves to get 343? Or, if you want to look at it this way, what number times itself is 343? And for the most part, we're going to memorize these numbers. I'm going to let you know that the answer to this one is the number 7. That's from a memorization chart that we're going to work with. If you find yourself stuck or not understanding, we are going to do more with squares and cube roots, but this should be enough to get you started. And with that said, good luck on Unit 2, Day 1 and 2.